Part A is just implicit differentiation problem. So take your normal derivatives, but if you take derivative y's in it, tag on a y prime. So go 8y, tag on a y prime. Remember your product rule right here, dude. The first times root of the second plus the second times root of the first. And then remember your technique, your algebraic technique is you move all of your y primes on the same side of that equation, factor out a y prime and divide, and then boom, there's your derivative there. So I like those problems when they ask me to show something and I actually can obtain that, then I know I did that thing right. So that's just doing implicit differentiation, getting that first derivative. Part B, it says, show that there's a point with x coordinate 3 at which the line tangent to the curve is horizontal. So horizontal tangent line, you know the slope of a horizontal line is 0. So if the slope is 0, that means the derivative is 0. So I'm going to take this derivative, set it equal to 0, and then we know a fraction is equal to 0 or the top is equal to 0. So I'm going to set that top part equal to 0. They told me the x value was 3. That's where I got 3y minus 6 equals 0. And then we're going to get this y value is equal to 2. So that's how we obtain that y value. Now, see this word show, that there's a point P? Just because it says that word show, I'm probably going to be a little bit more technical there. So I'm actually going to show that this point 3, 2 is on this original curve. So just in case, I just plugged in the 3 for the x and the 2 for the y, show that I did get 25, because 25 I did get something true, which means that, hey, I showed the points on the curve, and I also said, hey, that's where the derivative is equal to 0 right there. That's where you got a horizontal tangent line. Letter C, the first part, this is the notation for the second derivative. So I need to go to this guy here and then do a quotient rule. Okay, so I did the denominator times by the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Just when you do the derivative y's in it, still tag in the y prime. Okay, so there's my basic quotient rule. Now, usually in the past, we would simplify that, we would factor it, we would get rid of the y prime, and it would be a little bit more chaotic algebraically. But notice that we're using the point from part A, all right? So, sorry, on part B. So we're going to use this point that we found in part B. And then everywhere I see an x, I'm going to plug in a 3. Everywhere I see a y, I'm going to plug in a 2. So you got to be really careful with that. Also, whenever you see the y prime, we said in part B at this point that dy dx is equal to 0, which means that's your derivative. Your y prime is equal to 0. So everywhere you see a y prime, you can plug in a 0 right there. So that's why I'm plugging in the 0 for the y prime. I'm plugging in the 2 for the y, so get like a 16. Plug in a 3 for the x, getting the 16 minus 9 right there. Just there is no calculator on this problem. So some of you, that's why I'm concerned most about. You just got to be really careful with your arithmetic. I mean, you got points there automatically as long as you find that second derivative, but then plugging in the numbers there and then simplifying that. If the fraction ever gets too large and you're not sure what it simplifies to, you don't necessarily have to take it down that far. You just have to find the answer. It doesn't matter if that fraction is simplified or not. Just get that correct answer right there. So just practice that on your own. Be careful with your arithmetic right there. And then the last part of it, after you find that, it wants to know, does the curve have a local max, a local min, or neither at that point P? Now, I mentioned this in a prior video, but they red flag this always from a mile away. When they have us find the second derivative and they turn right around and ask us, is something a max, min, or neither, they're meaning for us to look at the double D, the second derivative test right there, okay? If your first derivative is 0, that means your graph is going to level off. If your second derivative is positive, that means your graph is concave up. So if it levels off and it's concave up, holding the water, that forces that to be a relative min. If your first derivative is 0 and levels off and your second derivative is negative, that means your graph is concave down. That forces that to be a high point in that area. So check out that blue packet if you need to. You don't have to call this the second derivative test, but we know at this point the first derivative is 0 and we obtained that the second derivative was negative. So if I forget that concept, I just kind of close my eyes for a second. When I see second derivative negative, that's concave down. So that means there's going to be a high point right there. So that's why I said, hey, the curve has a local max since the y prime is 0 and the y double prime is negative. Those are the two items you need to have. You don't need to call it the second derivative test, but you do need to mention those two items right there. Snowman.